All right, you guys, we have two more videos or two more examples to get through for today where we're seeing different applications and how we can use our systems to solve the applications. So we just wrapped up an explanation on mixing together chemicals. So we're going to look at another mixture problem, but this time we're going to mix together candy. So this problem says, Chloe is creating a candy mixture for her Halloween party. She wants to put candy corn and gummy worms in a big bowl. How much candy corn, that costs 80 cents per pound, should she mix with 8 pounds of gummy worms that are $1.25 per pound to get a mixture that costs $1 per pound overall? So again, this is a very similar type of problem to ones that you will see on many standardized assessments, on your ACT and things like that. So it's really good to just distill this problem to what are we trying to figure out? What things do we not know? What things do we know, and how can we use those to solve for the unknown quantities? So here, Chloe is creating a candy mixture, and she has two different things going on. She's got candy corn, and she's got gummy worms. So what it's asking us is, how much candy corn should she mix in with gummy worms to get a new mixture? So if we think about our variables, this one's going to be ever so slightly different from the most recent one. So we know how many gummy worms already that we're working with. We have 8 pounds of gummy worms. So the quantities that we don't know overall is just how much candy corn is going on. So let's call X the value for our candy corn. So we also don't know just the total amount of candy. So that's our other unknown. We know one of the quantities, but we don't know the other, so that means we no longer know the total amount. Before we knew the total, but we didn't know each of the individual quantities. So what we want to think about here is if we add X plus however many pounds of gummy worms we have, which is 8, we're going to get to the total. So this equation here, X plus 8 equals Y, represents the total amount of candy in pounds. Because if I already have 8 pounds of gummy worms, and then I add in X, some amount of candy corn pounds, then that's how many pounds of candy overall we'll have. So in this equation, that is taking the 8 from here. We're trying to figure out how much of candy corn and how much of the overall mixture as weight values in pounds. Then we also need to have an equation that represents cost. So it tells us in the problem that candy corn costs 80 cents per pound. So we can represent that by 0.8 times X, so however many pounds of candy corn we have times the cost. Then we already know our 8 pounds of gummy worms, and those are $1.25 per pound. Then our Y value, the total, we don't know, but we do know that we want it to cost $1 overall. So this equation here represents the total cost of the mixture. Now this is kind of a funky thing to be mixing together, candy corn and gummy worms, but whatever kind of candy you like, this type of problem would work for that. So let's kind of think about whether we would want to use substitution or elimination here. When we come across our first equation, notice how we already have Y all by itself on one side. So that means that this equation I can already use as substitution. Then my second equation, if I look at this, I've got 0.8x plus 8 times $1.25. We can multiply in our calculator, and that's going to give us 10 is equal to $1 times Y is really just 1 times Y. So that's just equal to Y as well. So notice that I have an equation equal to Y here, an equation equal to Y here. So our work in substitution told us if we have one expression that's already equal to a variable and another expression that's also equal to that variable, then we can just set them equal to one another. So here I can say x plus 8, my first expression for Y, equals 0.8x plus 10, our second expression for Y. And then I can just combine like terms. So over here on this side, I'm going to subtract 10, and 8 minus 10 will give me negative 2. I can subtract x from this side, and subtract x here, and 0.8x minus x will give me negative 0.2x. From there, I can divide by negative 0.2. I can divide by negative 0.2 here. And my x value, if I divide negative 2 by negative 0.2, is going to give me 10. And remember, x represents how much candy corn we want. So we can say 10 pounds of candy corn. So then the nice thing is, we know how many gummy worm pounds we have. So to find the total amount, y equals x plus 8, well, we can just say y equals 10 plus 8. So our overall mixture is going to be 18 pounds in total. So that is one large candy mixture that they have for Halloween. So this process, I think, is a little bit more challenging than the chemical mixtures, because chemical mixtures is just x plus y equals total, and then percentage, percentage, percentage. Here we already had one of the total amounts, so one of the gummy worm total weights, and we needed to figure out candy corn weight and total weights. So it's just a little bit different organization of the problem setup. All right, you guys, last one that we're going to do today, we will save problem number 6 down here for our warm-up tomorrow. So the last one we'll do together today is this investment problem. These are the ones that are going to be very useful for real-world kind of math work. So if you ever go to put money in a savings account, or if you go to take out a loan, this kind of financial thinking is the methodology that you want to approach about how you'd be earning interest. And we'll talk a lot more about interest in some of our upcoming chapters. Here, this problem says, Jack Lantern decides to invest $2,000 in 2 different accounts. This should say he, not G. He puts some of the money in a savings account with a return of 5% over 5 years, and the rest in a money market account with a return of 8% over 5 years. After 5 years, he has earned $152.50 in interest. How much did he invest in each account? So if we look at problems like this, we have very similar situation actually to the chemical mixtures problem. Because notice that our final question is asking us, how much did he invest in each account? So Jack Lantern is putting his money into 2 different bank accounts. So one, X, that's going to be the money that's in his savings account. And then Y is going to be the money in his money market account. So a money market account is just a different kind of investment account from a savings account. So there's a certain amount of time that you would put it into that account and you wouldn't be able to access it while it was earning money. So he's dividing up overall. He starts out with $2,000 and he's putting it into savings and into money market. So if we add up the amount between those 2 different accounts, that has to be equal to 2,000. So we'll say X plus Y equals 2,000. Then what we want to think about is the interest that Jack is earning. So it says his savings account earns 5%. The money market earns 8%. So if we think about interest, 5% is going to be of the total amount that he put in. So his second equation should be 0.05x plus this percentage here will be 0.08y is equal to the total amount that he earned in interest, or 152.50. So before we had one equation when we were working with our mixture problem, one equation that described the total number of chemicals. Here, instead of total number of chemicals, we just have total money. So that's our first equation. Then with the chemical problem, we had one that was total acidity. Here we have total interest. So that's the money that you make when you invest your finances into an account. They accrue interest over time because the bank is investing them. So you're earning money from their investments on your behalf. So if we look at this system of equations, we need to get x or y by itself, and then we need to plug it back in to solve for the remaining variable. My recommendation here, because we have so many different decimals going on, is to use substitution so you don't have to try to multiply by weird decimals. So let's go ahead and get y by itself from this top equation. Y is going to be equal to 2,000 minus x. And so we're just going to plug that in for that y right there. So we'll have 0.05x plus 0.08 times 2,000 minus x is equal to 152.50. So then we just need to distribute and combine like terms. So we'll have 0.05x plus, here we need to multiply 2,000 by 0.08. So when I plug that into my calculator, I get 160. That's distributing here. Then I'm going to distribute over there. So minus 0.08x equals 152.50. Then let's combine our x's. So 0.05x minus 0.08x is going to give me negative 0.03x. And then I just want to subtract this 160 over to this side here. So if we have 152.50 minus 160, that leaves us with negative 7.5 or negative 750. Then to get x by itself, we're going to divide by negative 0.03. So into our calculators, we want to plug in 7.5 divided by 0.03. And that gives me an x value of $250 in savings. So into the first account that Jack has. So then we need to figure out how much he has remaining that he put in the money market account. So that's going to be pretty easy to evaluate. We can just use our original expression for y. So y is equal to 2,000 minus x. If we plug in 250 for x, we're going to end up with 1,750 left over in the money market account. So he's investing significantly more in one account than the other account to earn the interest amount that we were given. So that's where we're going to stop for today, you guys. Again, tomorrow when we come back for our warm-up, we're going to do another problem really similar to these. The only difference is that it's going to involve distance and travel. So just a different application, but same overall thought process. Then tomorrow, you're also going to get to write your own equation that's going to be Halloween themed. So you get to come up with kind of the basis for a problem and then show that it can be solved to obtain the same answer using different strategies. So tomorrow should be kind of a fun day. We'll draw some pictures to go along with our problems and just see all of the different ways that systems of equations can work in the real world. So please email me if you have any questions while attempting your homework problems tonight. You don't have too many, but there are going to all be application problems coming from your textbook. So go ahead and use the rest of class time to give those a try. And if you're in second or sixth hour, just call me over if you have questions. Again, if you're in fourth hour, if you have questions, please come see me after school or just shoot me an email. Thank you guys and enjoy the rest of your Monday.